Hello everyone, today I'm going to show you how to implement the sprite stacking rendering technique in the Go programming language with Ebitengine game engine. So, first of all, we're going to start with our image, and if you look here, I already have an image prepared. So as you can see, it's just a little box sprite sheet. So I have a, it's basically just a 2D slice of images, whereas when we render this using sprite stacking, it's going to be three-dimensional, and I'll show you how to do that. So basically, first of all, we have to actually load the image. So for that, we're going to use this command, ebitengine.newImage from file. So basically, we're going to put the name of the image, or the path to the image in this case, which is just box_sprite_sheet.png, and then we're going to actually take the result and an error value. So we're going to check if the error uh, is actually not equal to the nil value, which means the image failed to load, and we're just going to say image failed to load. Okay, so now what we can do is actually implement the sprite stacking rendering technique. So basically, first of all, let's just see if we can actually render this image. So I'm going to add this here. So first of all, we just add the ebitin.image right here, and we add this as a variable so we can just put it, I'll just move this over here, so we can just put this right here. And Golang is actually quite a nice programming language for game development in this case because it has very simple data-driven abstraction. So basically, we can just make abstractions by creating a struct. And in a future video, I'm going to make a video on structs, so stay tuned for that. So we can load this image. What's this error I'm getting here? Oh yeah, because that recurred. Okay, so we basically just have to discard the value, this value in the middle because we don't actually need that. We only need the ebitin image, not the image, which is something else. So now that we can load that, I'm going to see if I can render it. So to do that, we just use the draw image function. And if you've ever used something like Pygame before in Python, draw image is very similar to Python's .blit function. Basically, draw image allows you to take one image and paste it onto another image at a certain position with a certain configuration, etc. So I'm just going to create the draw options. So the draw options are basically a way to customize where the image actually goes. So in Pygame, you can only change the position, and you need to use other functions to modify stuff like the rotation, etc. But Golang allows us to do this all in one struct called draw image options. So we can use the geo matrix here to actually move the image. And now we have this, and it should work. So currently what we're doing isn't actually sprite stacking. If you notice, we're actually just drawing the image as a full 2D slice. But what we have to do is basically take these components here and put them onto each other to simulate a 3D object. And the way we're going to do that is by using a sprite sheet cutting. Basically, we're going to take the sprite sheet, which is the full two-dimensional image, and we're going to cut it into tiny frames. So I'll show you how to do that. So we're just going to use a Golang slice for this, which is similar to a Python list. If you've ever used Python, Golang slices are very similar to lists. Basically, they're just dynamic arrays that let you store multiple types or multiple values of the same type as many values as you want. Okay, so I'm just going to make this a pointer to an image. Okay, great. And we're going to actually allocate the slice. So now that we have that, we have to actually cut the image into the slices, into frames. And the way we're going to do that is by using a for loop. So I'm just going to do, let's see if I remember how to do this correctly. And why did I put 10? We're going to change this to the amount of frames there is. And let's just count that because I don't want to make it automatic for now. So if we look at this image, you'll see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 frames. So we'll just set this value to 15, and now we should be able to load the image. So the way we're going to do this is by allocating an image, let's just call it frame image, and then we're going to do ebitengine.new image, and there might even be a way to do this. Actually, never mind. Let's not do that. Okay. So we're going to allocate this new image. We're going to make it 32 by 32 because that's actually, if you look at our sprite stack, that's actually the size of each of these frames if you count the pixels. This is 32 by 32. So we're going to make it 32 by 32, and let me just check. Okay, yeah. We're going to fill it with transparency. And now what we're going to do is we're going to draw the sprite sheet on top of it. Actually, we're going to do frame image dot draw image, and then we're going to put the sprite sheet image, and we're going to put draw image options. Okay, yeah, so we have to allocate some options for the image drawing. Oh wait, I put the wrong thing. Draw image options. Okay, so I'm just going to pass address of here. And now what we can do is we can do the same thing we did earlier, and we just move it by a certain x and a certain y. So what we're going to do for that is we're going to multiply by 32. We're going to multiply I by 32 to get the offset in the x-axis. And I believe we have to make that negative because since we're doing a sprite sheet, we have to actually offset it the other way, if I'm doing this correctly. Uh, oh yeah, we have to cast this to a float 64. Yeah, unlike languages like Golang, unlike languages like Python, Go is actually statically typed, which means you need to make all of your variables have a explicit type. So I'm just going to put that there. Okay, now what we're doing is we're just appending the frame to the list or the slice of frames that is stored inside of our game struct. So now we should be able to draw one of these images. So let me just test that with the first one. Wonderful. So we're drawing the first image here. And if I understand, oh, why did that happen twice? If I understand correctly and I implemented this correctly, uh, this should draw the second image. Okay, wonderful, it works. So first of all, I'm just going to make the background a bit different so I can see the black cross on the box that I drew, so I can actually see it more clearly. Okay, wonderful. Now it's slightly more visible. Actually, I'm going to make that slightly lighter. Okay, great. That's better. Okay, so now that we actually have all the separate frames, what we can do is actually offset them by a certain y axis, by a certain y value. And this is basically the core of the sprite stacking rendering technique. So all we have to do is make a for loop for I image in range. So basically what this does is allows us to iterate or loop over the frames inside of the sprite sheet with an index and the actual image, which is basically like the value of the variable. So now we can draw that, and we'll create a new draw image options. and we're going to translate it. And the way we're going to translate it is actually by making this 100 and then doing minus I. And you'll see why we're doing this. So basically, oh, why is this not working? Oh, we have to, okay. Again, we have to cast this to a float 64 because, once again, Golang is statically typed. So if we do this, okay, it's not exactly working, I think. Yeah. Let's try to figure out why this isn't working. So basically what we're doing here is we're translating it by 100 and then doing 100 minus float 64I. So I think the reason it's not working, we might have to multiply this by a certain thing. Oh yeah, okay, wait, that's sort of working now. So what we're doing now, oh, okay, yeah, I understand why it's not working now, I believe. So what we basically see the issue here being is we have this image and it's kind of overlapping on top of this image. So that's kind of causing an issue. So the best way to fix this would I feel like would just be to multiply this by 2. Hmm. Okay, actually I think the reason it's not working is because we forgot to rotate it. So I forgot the core part of the sprite stacking technique is that you actually have to rotate the image. In this case, the unit is in radians, as you can see here. So we have to import the math package, I'm assuming, so we can actually cast the degrees to radians. So let's actually put an angle value here. And that's going to be initialized to 0 at the beginning. So basically what we do is instead of our update function, we can do box angle plus equals the delta time. Oh, what am I doing? The delta time. And then we can multiply that by something like 20. So we can do box angle. And here we do math dot. I believe we should be able to just convert this to radians somehow. Is there not a way to convert this to radians? I'm just gonna Google it. Okay, so it doesn't actually provide Golang doesn't actually provide a function, unfortunately, to convert degrees to radians and vice versa. That's kind of annoying, but I'll just implement that really quickly. Okay, so we'll multiply that by pi because we need the pi value to convert from radians to degrees and vice versa. So in this case, we can just use this function we made, and let's see what happens. Okay, so what we get here isn't exactly what's needed. Okay, let's see what's happened. Okay, yeah, this isn't exactly what we need here. Okay, wonderful. It actually works now. Okay, so now if you let me just change this to 1 so that it's slightly better. So now we have a three-dimensional object in Golang. And this might seem like magic because how are we rendering a 3D object from a collection of 2D images? But the way it actually works is basically we take each slice and kind of it's like a layer cake. We're basically taking each image and putting them on top of each other to create a full image. And if I actually just increase the resolution, we should be able to see it in a higher quality. Let me just make it scaled. So yeah, now you can see it in an even better resolution. Yeah, it's basically a high resolution 3D object now. And this technique can be expanded to do all kinds of different things. For example, if you want to draw, let's say something like a Minecraft world, you can use this as long as you sort the blocks correctly to make sure that the depth perception is correct. You can actually use this to render voxel-based worlds. But yeah, that's how to implement Golang sprite stacking using Ebitengine. So this technique is very powerful, and I'm definitely planning to use it in upcoming games I make. So yeah, stay tuned for that. All the code is going to be available in the description, by the way. So if anyone needs this code to follow along, and the image, yeah, the image will also be in the description. So anyway, thank you for watching, and please subscribe and have a nice day.